Hey, amazing people. What we're doing today is we're looking at compound interest. Now, to start off, the way we're going to look at compound interest is think about how it's using the simple interest formula, but we've got it compounding every single year to build up over time. So with this example here, we're told that Max invests $7,000 into a term deposit account for 3 years, where it earns 5% per annum. How much interest does he earn over the 3 years if the interest is paid into the term deposit at the end of each year? And B, we're asked, what is the future value of the investments? Okay, now first thing here is we need to be able to work it out for each year. So let's begin with year one. So as we calculate this here, this is going to be $7,000 plus $7,000 times 0.05. And as we calculate this, we get $7,350. Okay, let's move on to year two. Now for year two, we're using the amount we had at the end of year one to commence year two. So the $7,000 gets replaced by 7,350 in both instances, and we still times that by the same rate. And when we work this one out, then we get $7,717.50. Now, as we move on to year three now, we're using what we had at the end of year two to start year three. So now we have $7,717.50, and we're going to add to that $7,717.50 and times it by 0.05. And when we work this one out, we get $8,103.38. Now, over this time, we've had the amount accumulate. Now, one key aspect of this is we're asked to find the amount, the interest earned at the end of that period. So in order to work that out, what we have to do is take this amount here, 8,103 and 38, and minus what we started with. And in this case, then we have $1,103.38. That's the total interest earned over that period. Now for part B, we're asked what's the future value of the investment. Well, we've already calculated that because that's the interest plus the principal we started with at the beginning. So that's just going to be this amount here. So this is what the future value is at the end of those 3 years. Now, another way we could have calculated for this is we could have used the compound interest formula. Now, the compound interest formula is a formula which helps skip all these steps, so you can just get straight to the answer quite quickly. Now, in doing that, the formula you use is A equals P bracket 1 plus R to the power of N. Now, in this, what sometimes happens is they sometimes replace the A and the P in this. And when they do that, you have PV for present value and FV for future value. Present value being what's invested at the beginning, at the start of the time, and future value, what it's the investment is worth at the end of that period instead. So that's just one of those changes that you can sometimes come across. In this case here, we're going to stick to the original one with A and P in this case. So as we apply this to the previous question, we're just going to look at the future value part of the investment. Now, using the compound interest formula, it's much quicker for us to do. So all we're doing is we're going to take these numbers and put them into the formula. So our P in this case, which is our principal, that's going to be $7,000 because that's what we're starting with. Then we have a rate, which is 5%, and this can be written as 0.05. And then we have N, which is the number over the time period. In this case, it's 3 because it's only worked out at the end of every year. And so with A equals to that, if we just simplify this a little bit, just so we can understand what's happening, what we've got is $7,000 times 1.05 to the power of 3. When we work this one out, we get the same answer we just got, except it's a little bit quicker, and we can jump straight to the third year result. Now, another method which is sometimes used when dealing with compound interest is to use what's called a future value table. And when we're using a future value table, what it's doing is it's replacing the part of the compound interest formula, which is highlighted here. And so what happens is we end up effectively with A is equal to P times the value taken from the future interest table. Call it FV table value. And so this aspect here is taking it from a table like this one we can see here on the right. So if we were to apply that concept to that result we just did, what's going to happen? We're still going to have A is equal to 7,000, but what we're looking to replace is the 1.05 and to the power of 3. Now in this aspect, what we do is we look at the table here. Okay, so we've got a 5% interest rate. So that's the interest rate we're going to use here. Now, this was invested for 3 years. So we're just going to look until we've got a period of 3 years down here, and we see where the two of those intersect when we follow them across. And we can see that it's going to be this amount here. So rather than have 1.05 to the power 3, it's being replaced with this value here. So instead, we're going to times that by 1.1576. Now, when you type this into a calculator, we will get a slightly different result of this. And part of that is because of the rounded nature of a future value table. Generally, they're restricted to 4 decimal places. Just as an aside, if you took 1.05 to the power 3 and work this out, you would actually get 1.157625. So you can see that we've got these extra 2 decimal places here, which we don't have with the future value table. So now working this out, what we end up then is we end up with 8,103 and 20 cents. So you can see there's that slight difference in the cents. We've gone from 38 cents to 20 cents because of that rounding difference, which has occurred in the future value table. But this is another way compound interest can be calculated over time.